For nearly 4 decades, Moore's Law has been the governing dynamics of the computer industry, which in turn has impacted every industry. The exponential performance increase at constant cost and power has slowed. Yet, computing advance has gone to light speed. The warp drive engine is accelerated computing, and the energy source is AI. The arrival of accelerated computing and AI is timely, as industries tackle powerful dynamics, sustainability, generative AI, and digitalization. Without Moore's Law, as computing surges, data center power is skyrocketing, and companies struggle to achieve net zero. The impressive capabilities of generative AI created a sense of urgency for companies to reimagine their products and business models. Industrial companies are racing to digitalize and reinvent into software-driven tech companies, to be the disruptor and not the disrupted. Today, we will discuss how accelerated computing and AI are powerful tools for tackling these challenges and engaging the enormous opportunities ahead. We will share new advances in Nvidia's full-stack, data center scale, accelerated computing platform. We will reveal new chips, systems, acceleration libraries, cloud and AI services, and partnerships that open new markets. Welcome to GTC. GTC is our conference for developers. The global Nvidia ecosystem spans 4 million developers, 40,000 companies, and 14,000 startups. Thank you to our diamond sponsors for supporting us and making GTC 2023 a huge success. We're so excited to welcome more than 250,000 of you to our conference. GTC has grown incredibly. Only 4 years ago, our in-person GTC conference had 8,000 attendees. At GTC 2023, we'll learn from leaders like Demis Hassabis of DeepMind, Valerie Taylor of Argonne Labs, Scott Belsky of Adobe, Paul Debevec of Netflix, Thomas Schultes of ETH Zurich, and a special fireside chat I'm having with Ilya Sutskever, co-founder of OpenAI, the creator of ChatGPT. We have 650 amazing talks from the brightest minds in academia and the world's largest industries. There are more than 70 talks on generative AI alone. Other great talks like pre-trained multitask models for robotics, sessions on synthetic data generation, an important method for advancing AI, including one using Isaac Sim to generate physically based LiDAR point clouds. A bunch of talks on digital twins, from using AI to populate virtual factories of the future to restoring lost Roman mosaics of the past. Cool talks on computational instruments, including a giant optical telescope and a photon counting CT. Material science for carbon capture and solar cells, to climate science, including our work on Earth 2. Important works by Nvidia Research on trustworthy AI and AV safety. From computational lithography for microchips to make the smallest machines, to AI at the Large Hadron Collider to explain the universe. The world's most important companies are here, from auto and transportation, healthcare, manufacturing, financial services, retail, apparel, media and entertainment, telco, and of course, the world's leading AI companies. The purpose of GTC is to inspire the world on the art of the possible of accelerated computing and to celebrate the achievements of the scientists and researchers that use it.
I am a translator, transforming text into creative discovery. movement into animation, and direction into action. I am a healer, exploring the building blocks that make us unique, modeling new threats before they happen. And searching for the cures to keep them at bay. I am a visionary, generating new medical miracles. And giving us a new perspective on our sun to keep us safe here on Earth. I am a navigator, discovering a unique moment in a sea of content.
We're announcing the next generation.
And the perfect setting for any story. I am a creator, building 3D experiences from snapshots and adding new levels of reality to our virtual selves. I am a helper, bringing brainstorms to life.
Either bring from different angles.
Sharing the wisdom of a million programmers. And turning ideas into virtual worlds.
Build Northern Forest.
I even helped write the script. Breathed life into the words and composed the melody. I am AI, brought to life by Nvidia, deep learning, and brilliant minds everywhere.
Nvidia invented accelerated computing to solve problems that normal computers can't. Accelerated computing is not easy. It requires full-stack invention from chips, systems, networking, acceleration libraries, to refactoring the applications. Each optimized stack accelerates an application domain, from graphics, imaging, particle or fluid dynamics, quantum physics, to data processing and machine learning. Once accelerated, the application can enjoy incredible speedup, as well as scale-up across many computers. The combination of speedup and scale-up has enabled us to achieve 1,000,000x for many applications over the past decade, helping solve problems previously impossible. Though there are many examples, the most famous is deep learning. In 2012, Alex Kershevsky, Ilya Sutskever, and Jeff Hinton needed an insanely fast computer to train the AlexNet computer vision model. The researchers trained AlexNet with 14 million images on GeForce GTX 580, processing 262 quadrillion floating point operations. And the trained model won the ImageNet challenge by a wide margin and ignited the Big Bang of AI. A decade later, the transformer model was invented, and Ilya, now at OpenAI, trained the GPT-3 large language model to predict the next word. 323 sextillion floating point operations were required to train GPT-3. 1 million times more floating point operations than to train AlexNet. The result this time? ChatGPT, the AI heard around the world. A new computing platform has been invented. The iPhone moment of AI has started. Accelerated computing and AI have arrived. Acceleration libraries are at the core of accelerated computing. These libraries connect to applications, which connect to the world's industries, forming a network of networks. 3 decades in the making, several thousand applications are now NVIDIA accelerated, with libraries in almost every domain of science and industry. All NVIDIA GPUs are CUDA compatible, providing a large installed base and significant reach for developers. A wealth of accelerated applications attract end users, which creates a large market for cloud service providers and computer makers to serve. A large market affords billions in R&D to fuel its growth. NVIDIA has established the accelerated computing virtuous cycle. Of the 300 acceleration libraries and 400 AI models that span ray tracing and neural rendering, physical, earth, and life sciences, quantum physics and chemistry, computer vision, data processing, machine learning, and AI, we updated 100 this year that increased the performance and features of our entire install base. Let me highlight some acceleration libraries that solve new challenges and open new markets. The auto and aerospace industries use CFD for turbulence and aerodynamic simulation. The electronics industry uses CFD for thermal management design. This is Cadence's slide of their new CFD solver accelerated by CUDA. At equivalent system cost, NVIDIA A100 is 9 times the throughput of CPU servers. Or at equivalent simulation throughput, NVIDIA is 9 times lower cost or 17 times less energy consumed. Ansys, Siemens, Cadence, and other leading CFD solvers are now CUDA accelerated. Worldwide industrial CAE uses nearly 100 billion CPU core hours yearly. Acceleration is the best way to reclaim power and achieve sustainability and net zero. NVIDIA is partnering with the global quantum computing research community. The NVIDIA Quantum Platform consists of libraries and systems for researchers to advance quantum programming models, system architectures, and algorithms. cuQuantum is an acceleration library for quantum circuit simulations. IBM Qiskit, Google Cirq, Baidu Quantum Leaf, QMware, QEra, Xanadu Penny Lane, Agnostic, and AWS Bracket have integrated cuQuantum into their simulation frameworks. Open Quantum CUDA is our hybrid GPU quantum programming model. IonQ, Orca Computing, Atom, QEra, Oxford Quantum Circuits, IQM, Pascal, Quantum Brilliance, Quantinuum, Rigetti, Xanadu, and Enneon have integrated Open Quantum CUDA. Error correction on a large number of qubits is necessary to recover data from quantum noise and decoherence. Today, we're announcing a quantum control link, developed in partnership with Quantum Machines, that connects NVIDIA GPUs to a quantum computer to do error correction at extremely high speeds. Though commercial quantum computers are still a decade or two away, we're delighted to support this large and vibrant research community with NVIDIA Quantum. Enterprises worldwide use Apache Spark to process data lakes and warehouses, SQL queries, graph analytics, and recommender systems. Spark Rapids is NVIDIA's accelerated Apache Spark data processing engine. Data processing is the leading workload of the world's $500 billion cloud computing spend. Spark Rapids now accelerates major cloud data processing platforms, including GCP Dataproc, Amazon EMR, Databricks, and Cloudera. Recommender systems use vector databases to store, index, search, and retrieve massive datasets of unstructured data. A new important use case of vector databases is large language models to retrieve domain-specific or proprietary facts that can be queried during text generation. We are introducing a new library, Raft, to accelerate indexing, loading the data, and retrieving a batch of neighbors for a single query. We are bringing the acceleration of Raft to Meta's open source Phase AI similarity search, Milvus open source vector database used by over 1,000 organizations, and Redis with over 4 billion Docker pools. Vector databases will be essential for organizations building proprietary large language models. 22 years ago, operations research scientists Lee and Lim posted a series of challenging pickup and delivery problems. PDP shows up in manufacturing, transportation, retail and logistics, and even disaster relief. PDP is a generalization of the traveling salesperson problem and is NP hard, meaning there is no efficient algorithm to find an exact solution. The solution time grows factorially as the problem size increases. Using an evolution algorithm and accelerated computing to analyze 30 billion moves per second, Nvidia cuOpt has broken the world record and discovered the best solution for Lee and Lim's challenge. AT&T routinely dispatches 30,000 technicians to service 13 million customers across 700 geographic zones. Today, running on CPUs, AT&T's dispatch optimization takes overnight. AT&T wants to find a dispatch solution in real time that continuously optimizes for urgent customer needs and overall customer satisfaction, while adjusting for delays and new incidents that arise. With cuOpt, AT&T can find a solution 100 times faster and update their dispatch in real time. AT&T has adopted a full suite of Nvidia AI libraries. In addition to Spark Rapids and cuOpt, they're using Riva for conversational AI and Omniverse for digital avatars. AT&T is tapping into Nvidia accelerated computing and AI for sustainability, cost savings, and new services. cuOpt can also optimize logistics services. 400 billion parcels are delivered to 377 billion stops each year. Deloitte, Capgemini, SoftServe, Accenture, and Quantify are using Nvidia cuOpt to help customers optimize operations. NVIDIA's inference platform consists of 3 software SDKs. NVIDIA TensorRT is our inference runtime that optimizes for the target GPU. NVIDIA Triton is a multi-framework data center inference serving software supporting GPUs and CPUs. Microsoft Office and Teams, Amazon, American Express, and the U.S. Postal Service are among the 40,000 customers using TensorRT and Triton. Uber uses Triton to serve hundreds of thousands of ETA predictions per second. With over 60 million daily users, Roblox uses Triton to serve models for game recommendations, build avatars, and moderate content and marketplace ads. We are releasing some great new features: Model Analyzer support for model ensembles, multiple concurrent model serving, and multi-GPU, multi-node inference for GPT-3 large language models. NVIDIA Triton Management Service is our new software that automates the scaling and orchestration of Triton inference instances across a data center. Triton Management Service will help you improve the throughput and cost efficiency of deploying your models. 50 to 80% of cloud video pipelines are processed on CPUs, consuming power and cost and adding latency. CV CUDA for computer vision and VPF for video processing are new cloud-scale acceleration libraries. CV CUDA includes 30 computer vision operators for detection, segmentation, and classification. VPF is a Python video encode and decode acceleration library. Tencent uses CV CUDA and VPF to process 300,000 videos per day. Microsoft uses CV CUDA and VPF to process visual search. Runway is a super cool company that uses CV CUDA and VPF to process video for their cloud generative AI video editing service. Already, 80% of internet traffic is video. User-generated video content is driving significant growth and consuming massive amounts of power. We should accelerate all video processing and reclaim the power. CV CUDA and VPF are in early access. Nvidia accelerated computing helped achieve a genomics milestone. Now doctors can draw blood and sequence a patient's DNA in the same visit. In another milestone, Nvidia-powered instruments reduced the cost of whole genome sequencing to just $100. Genomics is a critical tool in synthetic biology, with applications ranging from drug discovery and agriculture to energy production. Nvidia Parabricks is a suite of AI-accelerated libraries for end-to-end genomics analysis in the cloud or in instrument. Nvidia Parabricks is available in every public cloud, and genomics platforms like Terra, DNA Nexus, and FormBio. Today, we're announcing Parabricks 4.1, and will run on Nvidia accelerated genomics instruments from PacBio, Oxford Nanopore, Ultima, Singular, BioNano, and NanoString. The world's $250 billion medical instruments market is being transformed. Medical instruments will be software-defined and AI-powered. NVIDIA Holoscan is a software library for real-time sensor processing systems. Over 75 companies are developing medical instruments on Holoscan. Today, we are announcing Medtronic, the world leader in medical instruments, and NVIDIA are building their AI platform for software-defined medical devices. This partnership will create a common platform for Medtronic systems, ranging from surgical navigation to robotic-assisted surgery. Today, Medtronic announced that its GI Genius system, with AI for early detection of colon cancer, is built on NVIDIA Holoscan and will ship around the end of this year. The chip industry is the foundation of nearly every industry. Chip manufacturing demands extreme precision, producing features 1,000 times smaller than a bacterium, and on the order of a single gold atom, or a strand of human DNA. Lithography, the process of creating patterns on a wafer, is the beginning of the chip manufacturing process and consists of two stages: photomask making and pattern projection. It is fundamentally an imaging problem at the limits of physics. The photomask is like a stencil of a chip. Light is blocked or passed through the mask to the wafer to create the pattern. The light is produced by the ASML EUV Extreme Ultraviolet Lithography System. Each system is more than $250 million. ASML EUV uses a radical way to create light: laser pulses firing 50,000 times a second at a drop of tin, vaporizing it, creating a plasma that emits 13.5 nanometer EUV light, nearly X-ray. Multi-layer mirrors guide the light to the mask. The multi-layer reflectors in the mask reticle take advantage of interference patterns of the 13.5 nanometer light to create finer features down to 3 nanometers. Magic. The wafer is positioned within 1/4 of a nanometer and aligned 20,000 times a second to adjust for any vibration. The step before lithography is equally miraculous. Computational lithography applies inverse physics algorithms to predict the patterns on the mask that will produce the final patterns on the wafer. In fact, the patterns on the mask do not resemble the final features at all. Computational lithography simulates Maxwell's equations of the behavior of the light passing through optics and interacting with photoresists. Computational lithography is the largest computation workload in chip design and manufacturing, consuming tens of billions of CPU hours annually. Massive data centers run 24/7 to create reticles used in lithography systems. These data centers are part of the nearly $200 billion annual capex invested by chip manufacturers. Computational lithography is growing fast as algorithm complexity increases, enabling the industry to go to 2 nanometers and beyond. Nvidia today is announcing cuLitho, a library for computational lithography. cuLitho, a massive body of work that has taken nearly 4 years, and with close collaboration with TSMC, ASML, and Synopsys, accelerates computational lithography by over 40 times. There are 89 reticles for the Nvidia H100. Running on CPUs, a single reticle currently takes 2 weeks to process. cuLitho, running on GPUs, can process a reticle in a single 8-hour shift. TSMC can reduce their 40,000 CPU servers used for computational lithography by accelerating with cuLitho on just 500 DGX H100 systems, reducing power from 35 megawatts to just 5 megawatts. With cuLitho, TSMC can reduce prototype cycle time, increase throughput, and reduce the carbon footprint of their manufacturing, and prepare for 2 nanometer and beyond. TSMC will be qualifying cuLitho for production starting in June. Every industry needs to accelerate every workload so that we can reclaim power and do more with less. Over the past 10 years, cloud computing has grown 20% annually into a massive $1 trillion industry. Some 30 million CPU servers do the majority of the processing. There are challenges on the horizon. As Moore's Law ends, increasing CPU performance comes with increased power. And the mandate to decrease carbon emissions is fundamentally at odds with the need to increase data centers. Cloud computing growth is power limited. First and foremost, data centers must accelerate every workload. Acceleration will reclaim power. The energy saved can fuel new growth. Whatever is not accelerated will be processed on CPUs. The CPU design point for accelerated cloud data centers differs fundamentally from the past. In AI and cloud services, accelerated computing offloads parallelizable workloads, and CPUs process other workloads like WebRPC and database queries. We designed the Grace CPU for an AI and cloud-first world, where AI workloads are GPU accelerated, and Grace excels at single-threaded execution and memory processing. It's not just about the CPU chip. Data center operators optimize for throughput and total cost of ownership of the entire data center. We designed Grace for high energy efficiency at cloud data center scale. Grace comprises 72 ARM cores, connected by a super high-speed on-chip scalable coherent fabric that delivers 3.2 terabytes per second of cross-sectional bandwidth. Grace Superchip connects 144 cores between 2 CPU dies over a 900 gigabytes per second, low-power, chip-to-chip coherent interface. The memory system is LPDDR, low-power memory, like used in cell phones, that we specially enhanced for use in data centers. It delivers 1 terabytes per second, 2.5 times the bandwidth of today's systems at 1/8 the power. The entire 144-core Grace Superchip module with 1 terabyte of memory is only 5 by 8 inches. It is so low power, it can be air-cooled. This is the computing module with passive cooling. 2 Grace Superchip computers can fit in a single 1U air-cooled server. Grace's performance and power efficiency are excellent for cloud and scientific computing applications. We tested Grace on a popular Google benchmark, which tests how quickly cloud microservices communicate, and HighBench Suite that tests Apache Spark memory-intensive data processing. These kinds of workloads are foundational for cloud data centers. At microservices, Grace is 1.3 times faster than the average of the newest generation x86 CPUs, and 1.2 times faster at data processing. And that higher performance is achieved using only 60% of the power measured at the full server node. CSPs can outfit a power-limited data center with 1.7 times more Grace servers, each delivering 25% higher throughput. At ISO power, Grace gives CSPs 2 times the growth opportunity. Grace is sampling, and ASUS, ATOS, Gigabyte, HPE, QCT, Supermicro, Wistron, and ZT are building systems now. In a modern software-defined data center, the operating system doing virtualization, network, storage, and security can consume nearly half of the data center's CPU cores and associated power. Data centers must accelerate every workload to reclaim power and free CPUs for revenue-generating workloads. Nvidia Bluefield offloads and accelerates the data center operating system and infrastructure software. Over 24 ecosystem partners, including Checkpoint, Cisco, DDN, Dell EMC, Juniper, Palo Alto Networks, Red Hat, and VMware, use Bluefield's data center acceleration technology to run their software platforms more efficiently. Bluefield 3 is in production and adopted by leading cloud service providers Baidu, CoreWeave, JD.com, Microsoft Azure, Oracle OCI, and Tencent Games to accelerate their clouds. NVIDIA accelerated computing starts with DGX, the world's AI supercomputer, the engine behind the large language model breakthrough. I hand-delivered the world's first DGX to OpenAI. Since then, half of the Fortune 100 companies have installed DGX AI supercomputers. DGX has become the essential instrument of AI. The GPU of DGX is 8 H100 modules. H100 has a transformer engine designed to process models like the amazing GPT, which stands for Generative Pre-trained Transformers. The 8 H100 modules are NV-linked to each other across NV-link switches to allow fully non-blocking transactions. The 8 H100s work as one giant GPU. The computing fabric is one of the most vital systems of the AI supercomputer. 400 gigabits per second, ultra-low latency, NVIDIA Quantum InfiniBand with in-network processing connects hundreds and thousands of DGX nodes into an AI supercomputer. NVIDIA DGX H100 is the blueprint for customers building AI infrastructure worldwide. It is now in full production. I am thrilled that Microsoft announced Azure is opening private previews to their H100 AI supercomputer. Other systems and cloud services will soon come from Atos, AWS, Cirruscale, CoreWeave, Dell, Gigabyte, Google, HPE, Lambda, Lenovo, Oracle, Quanta, and Supermicro. The market for DGX AI supercomputers has grown significantly. Originally used as an AI research instrument, DGX AI supercomputers are expanding into operations, running 24/7 to refine data and process AI. DGX supercomputers are modern AI factories. We are at the iPhone moment of AI. Startups are racing to build disruptive products and business models, while incumbents are looking to respond. Generative AI has triggered a sense of urgency in enterprises worldwide to develop AI strategies. Customers need to access NVIDIA AI easier and faster. We are announcing NVIDIA DGX Cloud through partnerships with Microsoft Azure, Google GCP, and Oracle OCI to bring NVIDIA DGX AI supercomputers to every company instantly from a browser. DGX Cloud is optimized to run NVIDIA AI Enterprise, the world's leading acceleration library suite for end-to-end development and deployment of AI. DGX Cloud offers customers the best of NVIDIA AI and the best of the world's leading cloud service providers. This partnership brings NVIDIA's ecosystem to the CSPs while amplifying NVIDIA's scale and reach. This win-win partnership gives customers racing to engage generative AI instant access to NVIDIA in global scale clouds. We are excited by the speed, scale, and reach of this cloud extension of our business model. Oracle Cloud Infrastructure, OCI, will be the first NVIDIA DGX cloud. OCI has excellent performance. They have a two-tier computing fabric and management network. NVIDIA CX7, with the industry's best RDMA, is the computing fabric. And Bluefield 3 will be the infrastructure processor for the management network. The combination is a state-of-the-art DGX AI supercomputer that can be offered as a multi-tenant cloud service. We have 50 early access enterprise customers spanning consumer internet and software, healthcare, media and entertainment, and financial services. ChatGPT, Stable Diffusion, DALL-E, and Midjourney have awakened the world to generative AI. These applications' ease of use and impressive capabilities attracted over 100 million users in just a few months. ChatGPT is the fastest growing application in history. No training is necessary. Just ask these models to do something. The prompts can be precise or ambiguous. If not clear, through conversation, ChatGPT learns your intentions. The generated text is beyond impressive. ChatGPT can compose memos and poems, paraphrase a research paper, solve math problems, highlight key points of a contract, and even code software programs. ChatGPT is a computer that not only runs software, but writes software. Many breakthroughs led to generative AI. Transformers learn context and meaning from the relationships and dependency of data, in parallel and at large scale. This led to large language models that learn from so much data they can perform downstream tasks without explicit training. And diffusion models, inspired by physics, learn without supervision to generate images. In just over a decade, we went from trying to recognize cats to generating realistic images of a cat in a spacesuit walking on the moon. Generative AI is a new kind of computer, one that we program in human language. This ability has profound implications. Everyone can direct a computer to solve problems. This was a domain only for computer programmers. Now, everyone is a programmer. Generative AI is a new computing platform like PC, internet, mobile, and cloud. And like in previous computing eras, first movers are creating new applications and founding new companies to capitalize on generative AI's ability to automate and co-create. Debuild lets users design and deploy web applications just by explaining what they want. Grammarly is a writing assistant that considers context. Tab 9 helps developers write code. OmniKey generates customized ads and copy. Core AI is a virtual customer service agent. Jasper generates marketing material. Jasper has written nearly 5 billion words, reducing time to generate the first draft by 80%. InSilico uses AI to accelerate drug design. Absci is using AI to predict therapeutic antibodies. Generative AI will reinvent nearly every industry. Many companies can use one of the excellent generative AI APIs coming to market. Some companies need to build custom models with their proprietary data that are experts in their domain. They need to set up usage guardrails and refine their models to align with their company's safety, privacy, and security requirements. The industry needs a foundry, a TSMC, for custom large language models. Today, we announce the NVIDIA AI Foundations, a cloud service for customers needing to build, refine, and operate custom large language models and generative AI, trained with their proprietary data and for their domain-specific tasks. NVIDIA AI Foundations comprise language, visual, and biology model making services. NVIDIA NeMo is for building custom language text-to-text generative models. Customers can bring their model or start with the NeMo pre-trained language models, ranging from GPT-8, GPT-43, and GPT 530 billion parameters. Throughout the entire process, NVIDIA AI experts will work with you, from creating your proprietary model to operations. Let's take a look.
Generative models, like NVIDIA's 43B foundational model, learn by training on billions of sentences and trillions of words. As the model converges, it begins to understand the relationships between words and their underlying concepts captured in the weights in the embedded space of the model. Transformer models use a technique called self-attention, a mechanism designed to learn dependencies and relationships within a sequence of words. The result is a model that provides the foundation for a ChatGPT-like experience. These generative models require expansive amounts of data, deep AI expertise for data processing and distributed training, and large-scale compute to train, deploy, and maintain at the pace of innovation. Enterprises can fast-track their generative AI adoption with NVIDIA NeMo service running on NVIDIA DGX Cloud. The quickest path is starting with one of NVIDIA's state-of-the-art, pre-trained foundation models. With the NeMo service, organizations can easily customize a model with p-tuning to teach it specialized skills, like summarizing financial documents, creating brand-specific content, and composing emails with personalized writing styles. Connecting the model to a proprietary knowledge base ensures that responses are accurate, current, and cited for their business. Next, they can provide guardrails by adding logic and monitoring inputs, outputs, toxicity, and bias thresholds so it operates within a specified domain and prevents undesired responses. After putting the model to work, it can continuously improve with reinforcement learning based on user interactions. And NeMo's Playground is available for rapid prototyping before moving to the Cloud API for larger scale evaluation and application integration. Sign up for the NVIDIA NeMo service today to codify your enterprise's knowledge into a personalized AI model that you control.
Picasso is a visual language model making service for customers who want to build custom models, trained with licensed or proprietary content. Let's take a look.
Generative AI is transforming how visual content is created. But to realize its full potential, enterprises need massive amounts of copyright-cleared data, AI experts, and an AI supercomputer. NVIDIA Picasso is a cloud service for building and deploying generative AI-powered image, video, and 3D applications. With it, enterprises, ISVs, and service providers can deploy their own models. We are working with premier partners to bring generative AI capabilities to every industry. Organizations can also start with NVIDIA Edify models and train them on their data to create a product or service. These models generate images, videos, and 3D assets. To access generative AI models, applications send an API call with text prompts and metadata to Picasso. Picasso uses the appropriate model running on NVIDIA DGX Cloud to send back the generated asset to the application. This can be a photorealistic image, a high-resolution video, or a detailed 3D geometry. Generated assets can be imported into editing tools or into NVIDIA Omniverse to build photorealistic virtual worlds, metaverse applications, and digital twin simulations. With NVIDIA Picasso services running on NVIDIA DGX Cloud, you can streamline training, optimization, and inference needed to build custom generative AI applications. See how NVIDIA Picasso can bring transformative generative AI capabilities to your applications.
We are delighted that Getty Images will use the Picasso service to build Edify Image and Edify Video generative models, trained on their rich library of responsibly licensed professional images and video assets. Enterprises will be able to create custom images and video with simple text or image prompts. Shutterstock is developing an Edify 3D generative model, trained on their professional image, 3D, and video assets library. Shutterstock will help simplify the creation of 3D assets for creative production, digital twins, and virtual collaboration, making these workflows faster and easier for enterprises to implement. And I'm thrilled to announce a significant expansion of our longtime partnership with Adobe to build a set of next-generation AI capabilities for the future of creativity, integrating generative AI into the everyday workflows of marketers and creative professionals. The new generative AI models will be optimized for image creation, video, 3D, and animation. To protect artist rights, Adobe is developing with a focus on commercial viability and proper content attribution, powered by Adobe's Content Authenticity Initiative. Our third language domain is biology. Drug discovery is a nearly $2 trillion industry with $250 billion dedicated to R&D. Nvidia's Clara is a healthcare application framework for imaging, instruments, genomics, and drug discovery. The industry is now jumping onto generative AI to discover disease targets, design novel molecules or protein-based drugs, and predict the behavior of the medicines in the body. In silico medicine, Exscientia, Absci, and Evozyme are among hundreds of new AI drug discovery startups. Several have discovered novel targets or drug candidates that have started human clinical trials. BioNeMo helped researchers create, fine-tune, and serve custom models with their proprietary data. Let's take a look.
There are 3 key stages to drug discovery: discovering the biology that causes disease, designing new molecules, whether those are small molecules, proteins, or antibodies, and finally, screening how those molecules interact with each other. Today, generative AI is transforming every step of the drug discovery process. Nvidia BioNeMo service provides state-of-the-art generative AI models for drug discovery. It's available as a cloud service, providing instant and easy access to accelerated drug discovery workflows. BioNeMo includes models like AlphaFold, ESMFold, and OpenFold for 3D protein structure prediction, GPT for protein generation, ESM1 and ESM2 for protein property prediction, MegaMolBART and MoFlow for molecule generation, and DiffDock for molecule docking. Drug discovery teams can use the models through BioNeMo's web interface or cloud APIs. Here's an example of using Nvidia BioNeMo for drug discovery virtual screening. Generative models can now read a protein's amino acid sequence and, in seconds, accurately predict the structure of a target protein. They can also generate molecules with desirable ADME properties that optimize how a drug behaves in the body. Generative models can even predict the 3D interactions of a protein and molecule, accelerating the discovery of optimal drug candidates. With NVIDIA DGX Cloud, BioNeMo also provides on-demand supercomputing infrastructure to further optimize and train models, saving teams valuable time and money so they can focus on discovering life-saving medicines. The new AI drug discovery pipelines are here. Sign up now for access to NVIDIA BioNeMo service.
We will continue to work with the industry to include models into BioNeMo that encompass the end-to-end workflow of drug discovery and virtual screening. Amgen, AstraZeneca, Insilico Medicine, Evozyme, Innophore, and Alchemib Therapeutics are early access users of BioNeMo. NVIDIA AI Foundations, a cloud service, a foundry for building custom language models and generative AI. Since AlexNet a decade ago, deep learning has opened giant new markets: automated driving, robotics, smart speakers, and reinvented how we shop, consume news, and enjoy music. That's just the tip of the iceberg. AI is at an inflection point, as generative AI has started a new wave of opportunities, driving a step function increase in inference workloads. AI can now generate diverse data spanning voice, text, images, video, and 3D graphics to proteins and chemicals. Designing a cloud data center to process generative AI is a great challenge. On the one hand, a single type of accelerator is ideal because it allows the data center to be elastic and handle the unpredictable peaks and valleys of traffic. On the other hand, no one accelerator can optimally process the diversity of algorithms, models, data types, and sizes. Nvidia's One Architecture platform offers both acceleration and elasticity. Today, we are announcing our new inference platform. 4 configurations, 1 architecture, 1 software stack. Each configuration is optimized for a class of workloads. For AI video workloads, we have L4, optimized for video decoding and transcoding, video content moderation, and video call features like background replacement, relighting, making eye contact, transcription, and real-time language translation. Most cloud videos today are processed on CPUs. One 8-GPU L4 server will replace over 100 dual-socket CPU servers for processing AI video. Snap is a leading user of Nvidia AI for computer vision and recommender systems. Snap will use L4 for AV1 video processing, generative AI, and augmented reality. Snapchat users upload hundreds of millions of videos every day. Google announced today Nvidia L4 on GCP. Nvidia and Google Cloud are working to deploy major workloads on L4. Let me highlight 5. First, we're accelerating inference for generative AI models for cloud services like Wombo and Descript. Second, we're integrating Triton Inference Server with Google Kubernetes Engine and Vertex AI. Third, we're accelerating Google Dataproc with NVIDIA Spark Rapids. Fourth, we're accelerating AlphaFold and UL2 and T5 large language models. And fifth, we are accelerating Google Cloud's immersive stream that renders 3D and AR experiences. With this collaboration, Google GCP is a premier NVIDIA AI cloud. We look forward to telling you even more about our collaboration very soon. For Omniverse, graphics rendering, and generative AI like text-to-image and text-to-video, we are announcing L40. L40 is up to 10 times the performance of NVIDIA's T4, the most popular cloud inference GPU. Runway is a pioneer in generative AI. Their research team was a key creator of Stable Diffusion and its predecessor, Latent Diffusion. Runway is inventing generative AI models for creating and editing content. With over 30 AI magic tools, their service is revolutionizing the creative process, all from the cloud. Let's take a look.
Runway is making amazing AI-powered video editing and image creation tools accessible to everyone. Powered by the latest generation of NVIDIA GPUs running locally or in the cloud, Runway makes it possible to remove an object from a video with just a few brushstrokes, or apply different styles to video using just an input image, or change the background or the foreground of a video. What used to take hours using conventional tools can now be completed with professional broadcast quality results in just a few minutes. Runway does this by utilizing CV CUDA, an open source project that enables developers to build highly efficient GPU-accelerated pre- and post-processing pipelines for computer vision workloads and scale them into the cloud. With NVIDIA technology, Runway is able to make impossible things to give the best experience to content creators. What previously limited pros can now be done by you. In fact, Runway is used in Oscar-nominated Hollywood films, and we are placing this technology in the hands of the world's creators.
Large language models like ChatGPT are a significant new inference workload. GPT models are memory and computationally intensive. Furthermore, inference is a high-volume, scale-out workload and requires standard commodity servers. For large language model inference like ChatGPT, we are announcing a new Hopper GPU, the PCI Express H100, with dual GPU NVLink. The new H100 has 94 gigabytes of HBM3 memory. H100 can process the 175 billion parameter GPT-3, and supporting commodity PCI Express servers make it easy to scale out. The only GPU in the cloud today that can practically process ChatGPT is HGX A100. Compared to HGX A100, for GPT-3 processing, a standard server with 4 pairs of H100 with dual GPU NVLink is up to 10 times faster. H100 can reduce large language model processing costs by an order of magnitude. Grace Hopper is our new superchip that connects Grace CPU and Hopper GPU over a high-speed 900 gigabytes per second coherent chip-to-chip interface. Grace Hopper is ideal for processing giant datasets like AI databases for recommender systems and large language models. Today, CPUs with large memory store and query giant embedding tables, then transfer results to GPUs for inference. With Grace Hopper, Grace queries the embedding tables and transfers the results directly to Hopper across the high-speed interface, 7 times faster than PCI Express. Customers want to build AI databases several orders of magnitude larger. Grace Hopper is the ideal engine. This is NVIDIA's inference platform. One architecture for diverse AI workloads and maximum data center acceleration and elasticity. The world's largest industries make physical things, but they want to build them digitally. Omniverse is a platform for industrial digitalization that bridges digital and physical. It lets industries design, build, operate, and optimize physical products and factories digitally before making a physical replica. Digitalization boosts efficiency and speed and saves money. One use of Omniverse is the virtual bring-up of a factory, where all of its machinery is integrated digitally before the real factory is built. This reduces last-minute surprises, change orders, and plant opening delays. Virtual factory integration can save billions for the world's factories. The semiconductor industry is investing $500 billion to build a record 84 new fabs. By 2030, auto manufacturers will build 300 factories to make 200 million electric vehicles. And battery makers are building 100 more mega factories. Digitalization is also transforming logistics, moving goods through billions of square feet of warehouses worldwide. Let's look at how Amazon uses Omniverse to automate, optimize, and plan its autonomous warehouses.
Amazon Robotics has manufactured and deployed the largest fleet of mobile industrial robots in the world. The newest member of this robotic fleet is Proteus, Amazon's first fully autonomous warehouse robot. Proteus is built to move through our facilities using advanced safety, perception, and navigation technology. Let's see how Nvidia Isaac Sim, built on Omniverse, is creating physically accurate, photoreal simulations to help accelerate Proteus deployments. Proteus features multiple sensors that include cameras, LiDARs, and ultrasonic sensors to power its autonomy software systems. The The Proteus team needed to improve the performance of a neural network that read fiducial markers and helped the robot determine its location on the map. It takes a lot of data, and the right kind, to train the ML models that are driven by the robot sensor input. With Omniverse Replicator in Isaac Sim, Amazon Robotics was able to generate large photoreal synthetic datasets that improve the marker detection success rate from 88.6% to 98%. The use of synthetic data generated by Omniverse Replicator also sped up development times from months to days, as we were able to iteratively test and train our models much faster than when only using real data. To enable new autonomous capabilities for the expanding fleet of Proteus robots, Amazon Robotics is working towards closing the gap from simulation to reality, building large-scale multi-sensor, multi-robot simulations. With Omniverse, Amazon Robotics will optimize operations with full-fidelity warehouse digital twins. Whether we're generating synthetic data or developing new levels of autonomy, Isaac Sim on Omniverse helps the Amazon Robotics team save time and money as we deploy Proteus across our facilities.
Omniverse has unique technologies for digitalization, and Omniverse is the premier development platform for USD, which serves as a common language that lets teams collaborate to create virtual worlds and digital twins. Omniverse is physically based, mirroring the laws of physics. It can connect to robotic systems and operate with hardware in the loop. It features generative AI to accelerate the creation of virtual worlds, and Omniverse can manage datasets of enormous scale. We've made significant updates to Omniverse in every area. Let's take a look. Have downloaded Omniverse. Omniverse is not a tool, but a USD network and shared database, a fabric connecting to design tools used across industries. It connects, composes, and simulates the assets created by industry-leading tools. We are delighted to see the growth of Omniverse connections. Each connection links the ecosystem of one platform to the ecosystems of all the others. Omniverse's network of networks is growing exponentially. Bentley Systems Lumen RT is now connected. So are Siemens Teamcenter, NX, and Process Simulate. Rockwell Automation Emulate 3D, Cesium, Unity, and many more. Let's look at the digitalization of the $3 trillion auto industry and see how car companies are evaluating Omniverse in their workflows. Volvo Cars and GM use Omniverse USD Composer to connect and unify their asset pipelines. GM connects designers, sculptors, and artists using Alias, Siemens NX, Unreal, Maya, 3ds Max, and virtually assembles the components into a digital twin of the car. In engineering and simulation, they visualize the power flow aerodynamics in Omniverse. For next-generation Mercedes-Benz and Jaguar Land Rover vehicles, engineers use DriveSim in Omniverse to generate synthetic data to train AI models, validate the active safety system against a virtual NCAP driving test, and simulate real driving scenarios. Omniverse's generative AI reconstructs previously driven routes into 3D, so past experiences can be reenacted or modified. Working with IdealWorks, BMW uses Isaac Sim in Omniverse to generate synthetic data and scenarios to train factory robots. Lotus is using Omniverse to virtually assemble welding stations. Toyota is using Omniverse to build digital twins of their plants. Mercedes-Benz uses Omniverse to build, optimize, and plan assembly lines for new models. Rimac and Lucid Motors use Omniverse to build digital stores from actual design data that faithfully represent their cars. BMW is using Omniverse to plan operations across nearly 36 factories worldwide, and they are building a new EV factory completely in Omniverse 2 years before the physical plant opens. Let's visit.
The world's industries are accelerating digitalization with over $3.4 trillion being invested in the next 3 years. We at BMW strive to be leading edge in automotive digitalization. With Nvidia Omniverse and AI, we set up new factories faster and produce more efficiently than ever. This results in significant savings for us. It all starts with planning, a complex process in which we need to connect many tools, datasets and specialists around the world. Traditionally, we are limited since data is managed separately in a variety of systems and tools. Today, we've changed all that. We are developing custom Omniverse applications to connect our existing tools, know-how and teams all in a unified view. Omniverse is cloud native and cloud agnostic, enabling teams to collaborate across our virtual factories from everywhere. I'm about to join a virtual planning session for Debrecen in Hungary, our new EV factory opening in 2025. Let's jump in.
Milan is joining.
Hello everyone.
Hi Milan, great to see you. We're in the middle of an optimization loop for the body shop. Would you like to see?
Thanks, I'm highly interested. And I'd like to invite a friend.
Sure.
Hey Milan, good to see you.
Jensen, welcome to our virtual planning session.
It's great to be here. What are we looking at?
This is our global planning team who are working on a robot cell in Debrecen's digital twin. Matthias, tell us what's happening.
So we've just learned the production concept requires some changes. We are now reconfiguring the layout to add a new robot into the cell.
Okay, but if we add a new robot on the logistics side, we need to move our storage container.
All right, let's get this new robot in.
That's perfect. But let's double check. Can we run the cell? Excellent.
Milan, this is just incredible. Virtual factory integration is essential for every industry. I'm so proud to see what our teams did together. Congratulations.
We are working globally to optimize locally. After planning, operations is king. And we've already started. To celebrate the launch of our virtual plant, I'd like to invite you to open the first digital factory with me.
I'd be honored. Let's do it.
accessing and publishing shared data to Omniverse Nucleus. Designers and engineers working in their favorite third-party design tools on RTX workstations publish edits to Nucleus in parallel. Then, when ready to iterate or view their integrated model in Omniverse, can simply open a web browser and log in. As projects and teams scale, Omniverse Cloud helps optimize cost by provisioning compute resources and licenses as needed. And new services and upgrades are automatically provided with real-time updates. With Omniverse Cloud, enterprises can fast-track unified digitalization and collaboration across major industrial workflows, increasing efficiency, reducing costs and waste, and accelerating the path to innovation. See you in Omniverse.
Today, we announce the NVIDIA Omniverse Cloud, a fully managed cloud service. We're partnering with Microsoft to bring Omniverse Cloud to the world's industries. We will host it in Azure, benefiting from Microsoft's rich storage, security, applications, and services portfolio. We are connecting Omniverse Cloud to Microsoft 365 Productivity Suite, including Teams, OneDrive, SharePoint, and the Azure IoT Digital Twin services. Microsoft and Nvidia are bringing Omniverse to hundreds of millions of Microsoft 365 and Azure users. Accelerated computing and AI have arrived. Developers use Nvidia to speed up and scale up to solve problems previously impossible. A daunting challenge is net zero. Every company must accelerate every workload to reclaim power. Accelerated computing is a full-stack, data center scale computing challenge. Grace, Grace Hopper, and Bluefield 3 are new chips for super energy-efficient accelerated data centers. Acceleration libraries solve new challenges and open new markets. We updated 100 acceleration libraries, including cuQuantum for quantum computing, cuOpt for combinatorial optimization, and cuLitho for computational lithography. We are thrilled to partner with TSMC, ASML, and Synopsys to go to 2 nanometer and beyond. NVIDIA DGX AI supercomputer is the engine behind the generative large language model breakthrough. The DGX H100 AI supercomputer is in production and available soon from an expanding network of OEM and cloud partners worldwide. The DGX supercomputer is going beyond research and becoming a modern AI factory. Every company will manufacture intelligence. We are extending our business model with NVIDIA DGX Cloud by partnering with Microsoft Azure, Google GCP, and Oracle OCI to instantly bring NVIDIA AI to every company from a browser. DGX Cloud offers customers the best of NVIDIA and the best of the world's leading CSPs. We are at the iPhone moment for AI. Generative AI inference workloads have gone into overdrive. We launched our new inference platform, 4 configurations, 1 architecture, L4 for AI video, L40 for Omniverse and graphics rendering, H100 PCI Express for scaling out large language model inference, Grace Hopper for recommender systems and vector databases. NVIDIA's inference platform enables maximum data center acceleration and elasticity. NVIDIA and Google Cloud are working together to deploy a broad range of inference workloads. With this collaboration, Google GCP is a premier NVIDIA AI cloud. NVIDIA AI Foundations is a cloud service, a foundry, for building custom language models and generative AI. NVIDIA AI Foundations comprises language, visual, and biology model-making services. Getty Images and Shutterstock are building custom visual language models. And we're partnering with Adobe to build a set of next-generation AI capabilities for the future of creativity. Omniverse is the digital to physical operating system to realize industrial digitalization. Omniverse can unify the end-to-end workflow and digitalize the $3 trillion, 14 million employee automotive industry. Omniverse is leaping to the cloud. Hosted in Azure, we partner with Microsoft to bring Omniverse Cloud to the world's industries. I thank our systems, cloud, and software partners, researchers, scientists, and especially our amazing employees for building the Nvidia accelerated computing ecosystem. Together, we are helping the world do the impossible. Have a great GTC.